Next, we are going to talk about different types of system calls. So later you will see that they are corresponding to different major components or management, so which we have discussed in the previous chapter. The first component is process control or process management, which will help the user program to create a process, terminate a process, load or execute a process, hold the process for a period of time, suspend for a certain event, or generate a signal for event, and also allocate and free memory for a certain process. So later, when you work on some C programming assignment, so you will need those system calls to dynamically allocate some amount of memory for some process from the operating system. So after you finish to use them, you need to free those memory space back to the operating system so that it can be available for other process to use. And also the process control provides the locks, so which is used for process synchronization and communication. So when different processes need to access the shared data, especially if one process is updating the shared data, the lock is needed to temporarily protect the data to be accessed by other processes in order to guarantee the correctness. So later, we will talk about the locks in very detail, and also in some C programming assignments, so you will learn how to use them. And also, we have some system calls for other managements, which are very straightforward. For example, the file management and the device management. For file management, we need to create, delete, open, close file, and need to read and write the content with the file. And we'll also get and set the file attributes there. For device management, we need to request the device, release the device, read and write the content for the device, and also interact with the device attributes. So sometimes we need to logically attach or detach devices from the operating system. For example, you may attach your USB drive to your computer to access the content inside the USB drive. So when you finish the using, you need to detach the USB drive from the operating system. And all the operations which interact with the file and the device are relying on the corresponding system calls. There are other types of system calls, for example, information maintenance, which is used to get or set system time or date, and also get or set system data, and get or set process, file, or device attributes. And other types of system calls, which are very important for communications. And those system calls can help with create, delete communication connections. So there are two major communication approaches, which are message passing and shared memory, as we already mentioned in the previous chapter. So later we will discuss those two communication approaches in very detail. And here we just quickly go through each one of them. For message passing, one process initiates the communication connection to the other process. So one process serves as a client, and the other serves as a server. Then the client can send the data or message to the server. The message passing is not only widely used by multiple processes within the same computer, but also can be used by multiple processes to communicate with each other across different computers over the computer networks. For the shared memory, it is a very efficient way four processes sit in the same computer to access the shared memory block. So one process may be put or write the data into the shared memory. The other process can quickly grab the data and execute the data there, which is much more efficient. So compare message passing and the shared memory. The memory passing is quite simple and easy to implement, especially from the aspect of a programmer. So you just need to set up the connection between two processes. Then you can pass the data to each other through the message. And also, it is very good for small size of data exchanging through a message. On the other hand, so when you want to transfer larger size of data, the message passing way may not be suitable anymore. For example, the server wants to transfer 4 gigabyte of data to client. So it cannot wrap the entire 4 gigabyte of data within one message, then dump them into the connection. So when split the data into multiple messages, if one message gets lost on the way, actually the entire 4 gigabyte of data will becomes useless. However, for shared memory approach, so different processes within the same computer, they can directly share the same block of memory, so it is quite efficient. Perhaps the most efficient way within the same computer to exchange the data. So if this approach has been applied to handle the previous scenario, it can make the task much more convenient and efficient. However, on the other hand, so when using the shared memory approach, the coherence issue must be carefully handled. Like we have mentioned, the cache coherence problem in the previous chapter. So if one process is updating the data, it must be guaranteed that other processes who share the same block of memory will not mess up the data. Otherwise, they may face the coherence problem there. So the shared memory approach is much more complicated for implementation. So when you want to apply this approach on the communication between the processes on different computer, so you can imagine how complicated the implementation will be. So when people do communication across different computers, so they may simply choose message passing approach instead of choosing shared memory. Another type of system calls for protection. So where the system provides a service to the user to guarantee that the files, data, or resources of one user will not be accessed by other users. So here, some students may ask that, so why we don't talk about security? Because in the last chapter, we talk about the protection and the security together. You are right. Unfortunately, the system did not provide any system calls for security purpose because the system will do the security automatically without the interaction of users. The security problem is unpredictable. So the user program cannot request the security service explicitly from the system. So since the user never know when the virus or worms will attack the computer. Beside the system calls, the operating system provides system programs, which is usually treated as part of the operating system. The system programs can provide a convenient environment for program development and execution. For example, we also need system programs to help us manage the file system. So checking the system status information, such as, so what is the CPU occupation status? What is the memory occupation status? And how many processes are running in the system? Network status, and hard disk usage. So all those status information can be found in Task Manager on Windows system and Activity Monitor on Mac operating system. So for programming language support, some operating system will support some programming language by default. For example, the Linux operating system supports C programming language, so which means all the related components of a C programming language are already built in the system, such as the compiler, the linker, or editor, etc. And also, some system programs support other program loading and execution. For example, there are numbers of small programs to respond to users' actions. So when you click the mouse for a single time, it will choose the target icon. However, when you double click the mouse, the target icon will be opened and executed. So for communication, it's very important component for the users to connect with others. So in Windows operating system, you have IE or Edge to connect with the internet, then get information from the other side of the internet. For Mac OS, so you can use the Safari. And some background programs will be running inside the operating system secretly. For example, when the important update for operating system is available, the background program will download and install the update automatically, and the user actually don't even realize that. For the difference between system program and application program or user program is that so system programs come with the operating system. The user program is installed by user. So I'm not sure if you guys still remember, we have a talk about the web browser example in the previous chapter about the Firefox example. So for normal users who are not from computer science or electrical engineering major, so they don't do programming. So when they use the computer, they just use the normal applications, for example, word editing, photo processing, or web surfing, etc. So for their perspective to view the operating system, it's mainly relying on the system programs. So they don't even aware about the system calls. So actually, they don't even know what the system call is. On the other hand, so since you guys are taking this course, so you know what is the system call. And also you can use a different API to request the system services provided by the operating system.